everybody. Welcome. Thanks for getting up so early and be here bright and early for our session. My name is Sandra. I'm a product manager in Google Cloud, and here with me is Juan Oviedo, also a product manager in Cloud, and we have Rakesh Garala, senior product owner at ANZ. Here we're going to tell you all about the end-to-end security and compliance for your Kubernetes deployment. In today's talk, I will start by going over a few key concepts of supply chain security. Well, how does it work? How it used to work for VMs, and how container changes things up a bit. Then Rakesh is going to talk about NWAL at ANZ. Who is ANZ and what is NWAL? Then we'll introduce a few tools on GCP that will help you secure your software supply chain. And ANZ is going to go over a few key use cases they have and a demo of how it works in action. So I will get it started. First, supply chain security 101. When we talk about supply chain, the most common type of supply chain is food supply chain. Crops are planted, harvested, milled into flours, baked into bread, delivered to our dinner table. And then we ask questions about our food. We're like, is it organic? Where does it come from? Is it FDA approved? Very similarly, code goes through a similar type of cycle. Developers write code, code gets checked in, get baked into images, go through test and verification, and go through quality controls, and then deployed to our production environment, having access to super sensitive security resources. And then we have security stakeholders and compliance officers asking questions. Where does this code come from? Is it vulnerability free? Does it meet my compliance requirement? And most importantly, with all the requirements that I have to meet, how do I meet all of them without losing speed of my development? So traditionally for VM-based workloads, many customers run big monolithic applications that gets released only a few times a year due to its scale and the complexity involved to release it. For each release, security and compliance stakeholders have to manually inspect every component of the release to make sure that it's approved and it's up to date, it's vulnerability free. And because VM is an opaque format, this process is cumbersome, to say the least. And eventually, when the code is finally released to production, a number of people need access to the running applications fairly regularly to apply ongoing patches, ongoing maintenance, and fine-tuning. So this is a very manual process. And many different roles in the organization have direct access to the running application because they need to react to problems discovered during runtime. So it's a very reactive security model as well. So it's a process that we're probably all familiar with, but not necessarily love. How does container change things up? So Juan is going to tell us how that works.
Thank you, Sandra. Hello, everyone. So as we've seen with VMs, typically there are many manual steps that sometimes take a significant amount of time. This is manageable because of the number of components involved and the time between releases. Those two variables are very different in the world of containers. Microservices multiply the number of jobs an enterprise can run in production, and current CI/CD systems enable teams to have multiple deployments a day. Ensuring that the proper security checks are performed in each of these deployments is very challenging. Historically, the process of restricting what can be deployed has relied on human trust and operational knowledge, and that doesn't really scale to the volume of deployments that we see with containers. So now that we know about some of these challenges provided by containers, what are some of the properties that they offer that we can use to help us apply security while providing velocity? Containers have some unique properties. First, they are declarative, which means that as you build them, the set of libraries, versions, and components are clearly laid out. This also means that because of their declarative nature, they're also statically inspectable, which means that you can scan them for known security vulnerabilities as soon as they're built without needing to run the container image. And another key property is that they are immutable because they are uniquely identified by a digest that once created can't be altered. This enables you to track a particular container as it moves through your software supply chain. So given these properties, what are some steps that we can take to apply security while enabling our teams to create and move with velocity? First, we can build from trusted sources, which means using a set of pre-approved and regularly patched and maintained base images. These images should also have the minimal set of dependencies that are needed by your service, and it's something that should be controlled by, have a common base for your organization. Also, you should have streamlined security checkpoints as part of your release process. This means applying vulnerability scanning and other security-related tests as your artifacts move through the supply chain. And you should also define policies that enable you to apply consistent rules across different deployments performed by the different teams in your organization. So as we've seen, containers have some properties that present challenges, but also create opportunities to apply security while maintaining velocity. Now, I'm going to hand it over to Rakesh so he can tell us how ANZ is handling this space.
Thank you. Morning, everybody. So before we talk about what ANZ is doing, let's just explain who ANZ actually is. So we're a financial services institution based out of Australia. We are approximately, or probably the third largest bank within the region based on market cap. About 50,000 employees, 10 million customers, and we operate in probably over 30 to 32 countries, depends on how you classify that. So I just wanted to give you a bit of a view of kind of the size of our enterprise, the scale of kind of what we're trying to do, and how big we are and where we're based out of. So if you look at kind of what NWOW is, there were two key things that we identified. So one was the technology landscape was changing, and what that opened us up to was a different competitive landscape. Excuse me. We found that within Australia, fintechs, neobanks are really starting to actually disrupt the market. But what we also found was our customers had a different expectation. So in a digital world where technology's actually evolved and we're able to offer digital capabilities and digital services, we found that our customers wanted something very different from us as a banking institution. So we knew we needed to adapt, and what we decided was we were already building great customer experiences, but we felt that what we needed to do was build them much faster and build them at scale. And NWOW, or New Ways of Working, is our way of basically trying to achieve that. So NWOW is an organizational transformation. It starts with us reorganizing ourselves across squads, tribes, domains. So actually we're going to redesign, and we have been redesigning our organization. So you can see there, our CEO basically said he wanted to blow up our bureaucracy and actually get the organization much more customer-centric and product-focused. It doesn't stop there. We're also streamlining a lot of our organizational processes and our governance approaches. So what we wanted to do was strip and streamline as many of them as possible to allow our employees to actually focus on the consumer and embrace agility to deliver value to the consumer faster. Third and finally, and probably most importantly, technology is still something that we want to tackle and have been tackling. So we know as an organization that is over 180 years old. As part of this transformation, our technology landscape had to also evolve and change to shift to make advantage of the product centricity and the agility we're trying to embed with some of our organizational and process redesign. So what are we actually doing from a technology perspective? We're doing a whole range of things. I'm not going to talk to all of them. There's probably two key things that I want to highlight. So one is we want to continue our journey with containerization, which we started several years ago. So we felt then, and we still believe, that containerization gives us pace, it gives us greater stability, but probably most importantly, it allows us to build good technology with good practices. As part of that, though, what we've also identified is another opportunity. So what we've started to identify across the organization, which you'll see on the left-hand side of the picture, is we have very bespoke release practices. Some of that related to the things the guys have already talked about, but some of that related to as teams started to embrace containerization, they started to develop their own release practices and own automation in pockets and silos. So what we wanted to do was actually give the organization and give our engineers a way to develop, engineer, and actually push code to customers in an industrialized way, utilizing an industrialized CI/CD capability, which we're calling the paved roads, or as we've kind of referred to here already, is our supply chain. So the idea of this is that it doesn't just only help our engineers, but it also helps our customers get access to our products and features and value add a lot earlier. ANZ is a great place to work for a whole range of reasons, and I say that as an ANZ employee. But one of the key things for us is that we're a continually evolving and a learning organization. So we don't like to rest on ideas that we're starting to develop and push, but we kind of look for opportunities, and that's inbred in our culture and our DNA. So as we started to progress down these roads, we started to ask ourselves some kind of open questions to ourselves and said, what we're doing is good, but it's not great. So what we're doing opens us up for speed in pockets, but then how do we scale that? So the guys have already talked a little bit about containerization gives us scaling challenges. So we started to acknowledge what can we do to actually scale the work we're doing across the entire breadth of our enterprise. It also then opens us up to actually thinking about our operational processes. How can we govern, run, operate, and think about security better, and how do we actually start to embed that into our organization? And then, as we progressed past that, we started to think about how we automate governance. So can we automate a lot of the things that we would normally do as part of a supply chain manually? Can we automate that using some of these capabilities or using some of the new technologies available to us to make that even more streamlined? And the final bit for us was, I mentioned earlier, we operate across 30-odd countries. So the key thing for us is, what that means is we have 30 different regulators that manage financial institutions across those countries that we have to answer to. We have to show compliance to. We have to work within the breadth of remit that they give us within their country. So we're not just an organization delivering financial services in Australia, but because we work across 30 countries, we have 30 regulators to work with, and we continually are asking ourselves, is there a way that we can start to demonstrate compliance in a different way that will make our lives a little bit easier? So I've talked a little bit about what ANZ is, what we're trying to achieve, the reasons for kind of what we're trying to do. What I'm going to do is hand back over to Google to see if they can give us some insights into some products that can help with that journey. Juan?
Thank you, Rakesh. So let's take a moment to remember a great product experience that you had in the past. Remember the excitement you felt as you were opening that box and turning on that device, or as you were signing up for an account on that new service, or as you were being handed the keys to that new car. For you to get to that point, you had to make a decision to trust that that product was going to deliver on its promise. And for you to continue to use that product and continue to get value from it, you had to continue to believe that that trust was going to be fulfilled. So in essence, for customers to have a great customer experience, there has to be trust that the product will deliver on what it promises. And in order for your customers to give your product a try, they have to have that trust, but also for them to have the potential to eventually become loyal customers, that trust needs to be maintained. And security is key to maintaining that trust. And that's why at Google Cloud, we are focused on giving you solutions that enable you to apply security while enabling your teams to create and take advantage of the velocity provided by containers. So looking at the different stages of the software supply chain, we provide different solutions. Starting with Cloud Build, our CI/CD platform, you can use it to build different kinds of source code from different repositories. From there, you can make use of the managed base images that I will go into more detail soon. Then, as the different artifacts are built and the container images are pushed to container registry, we scan them for known security vulnerabilities. This gives you the ability to identify those issues early on and the opportunity to address them if needed. Then, you can use binary authorization to define deployment time policies to ensure that only artifacts that meet your organization's requirements can be deployed. And then, once your service is running, we continuously analyze the artifacts, and if there are any new security issues uncovered via known vulnerabilities, we make this information available to you. So now let's go into detail with some of these products, starting with Google Managed Base Images. Managed Base Images are maintained by us at Google. They are available for Debian, Ubuntu, and CentOS, and can be downloaded or obtained from our marketplace. They are scanned for known security vulnerabilities using GCR vulnerability scanning, and we regularly patch these images and keep them up to date. We use these images in our own products, such as App Engine, and they are a great resource that's available to you to start your development process from a secure base. Now, let's talk about Container Registry Vulnerability Scanning. Container Registry Vulnerability Scanning checks the images that you push to a registry for known security vulnerabilities. It supports scanning of images based on Ubuntu, Debian, Alpine, Red Hat, and CentOS. We continuously ingest data from the corresponding vendor security feeds, and if any new vulnerabilities are found that apply to your images, we make this information available to you. The product also has integration with pops-up notifications, which enables you to automate certain processes. For example, you could automatically notify certain members of your team when a new vulnerability is found, or you could automatically file a bug when vulnerabilities are found. Now, let's talk about Cloud Build for a moment. Cloud Build is our platform-provided CI/CD solution. With Cloud Build, you can build from different source code repositories. You can build different kinds of artifacts, such as Maven packages and container images. As I mentioned earlier, as the images are built and they're pushed to GCR, they're scanned for known vulnerabilities. You can also set up your corresponding tests as part of the Cloud Build process. And as the images and the different artifacts are deployed to your service, the whole experience is covered as part of the platform. So it's a great resource that's available to you. And now let's focus on the deployment piece, and I'll hand it over to Sandra so she can tell us how binary authorization can help you apply security at that stage.
Thank you, Juan.
Thank you.
So binary authorization. Binary authorization is a deploy time policy enforcement choke point. So what does it mean? It integrates with GKE deployment API, and it examines every deployment request that comes through the API to make sure that the image has proper signature that meets your customer-defined policy before it can be admitted into a production environment. The policy is configurable. You can define the right policy that works for your organization. So it may mean that something passes a particular security scan. It may mean that images are blessed by QA engineers. It may mean that the image is built by your trusted builder, or all three above. The binary authorization uses standard signature verification. So it can be plugged into your existing CI/CD tools if you don't choose to use the GCP-provided products. It just means that you have to put a signature on the image before it gets deployed. So the way it works is binary authorization integrates with your CI/CD pipeline and record a signature as the image passes through each of the stages in your CI/CD pipeline. And that signature signifies that the image has satisfied the requirement for that particular stage. For example, the builder would put a signature on your image saying, I'm the secure builder, I built this image. Or the scanner would put a signature on an image, basically means this image has satisfied my scanning policy requirement. And by the time the image comes to be deployed, at deploy time, there are a number of signatures already available for verification. Now, binary authorization takes a look of those signatures, compare with the policy that you've defined, and says, OK, this is a good image. You satisfy all the requirement in addition to just being deployed by an authorized person. So it's a two-level check. The right person's deploying it, and the right content is being deployed. If an image does not have the satisfactory signature on it, then binary authorization would block it and record a auto log for future reviews. There are break glass mechanisms available. So if your developer is trying to push a change that does not need the policy but needs to be applied anyway, they can break glass. And this would generate an auto log as well for your security team to review this incident later on. Some of the popular policies to be applied at runtime, as I mentioned earlier, are making sure the image is actually built by my organization, make sure the image has passed security checks, QA checks, integration checks, and so on. Or making sure that when I deploy a third-party image that I did not build, it meets a explicitly set whitelist that is managed by my security team. So we're releasing GA at this year's Google Next, so we're very happy that our products is going to be generally available. There are a few new features that we're pushing out with our GA release. One of those is the dry run feature. Dry run, it means that you're able to now set a policy in non-enforcement mode so that you can try out new deployment policies without risking production interruption. Again, we integrate with Cloud Autolog for any would-be blocked deployment attempt. And so we will record it in Autolog and can review that later on to make sure that everything's working fine before you turn on enforcement for real. And another new feature that is coming out is system container policies. So when you are running on GKE, there are a number of Google-owned system containers that are running in your cluster as part of the orchestration system. Things like containers used for logging or monitoring, for example. So even though these system containers are managed by Google, users could deploy an alternative version of these system containers to your cluster. And it's a attack surface. So how do we, before, customers basically have to make sure that, yes, I'm deploying the right versions of the system containers, making sure that those system containers are not being overridden. With binary authorization GA, we try to automate that for you. We have a default global policy that we created by working with the GKE release and build team to make sure that every system container that is built by Google, that built by GKE team, is signed. And that we're able to verify that signature for you at deploy time using this global system container policy if you opt in. So with this, on top of your existing customer-defined policy and third-party image whitelisting, you will have your entire cluster workload accounted for. So in your cluster, all the customer in-house built images will be signed by you. We'll have a signature requirement from your customer-defined policy. All the third-party images will be specified in the image whitelist that can be managed by your security team centrally. All the Google-owned system containers will be signed by the GKE release team and verified at deploy time as well. Last but not least, we also have Cloud KMS support in beta. So now you can sign your images using asymmetric keys managed in the Cloud KMS service. You don't have to have the hassle of managing your own keys anymore if you don't want to. And along with this, we also have generic PKCS key support. So if you have keys managed elsewhere in your preferred PKI, you can use those with binary authorization as well. So far I talked about the hosted binary authorization product and other vulnerability scanning base image products that we host on the GCP platform. But we also want to create an open platform. And that is why we created open source project, Grapheus plus Kritis, that are open source reference implementations of the container analysis metadata API and binary authorization that are available for any Kubernetes deployment anywhere. So we work with a number of industry partners, JFrog, Red Hat, IBM, Black Duck, Twistlock, and more, to create the standard metadata format so that they can be plugged in to your existing CI/CD pipeline. You may not have to use the Google-provided product to get the benefit of the secure framework. we want to create a knowledge base for you, so a metadata API, where you can record findings and facts about the containers that it's going through your CI/CD pipeline, that it's going to run on your security infrastructure. A knowledge base where you can like plug in metadatas, signatures, vulnerability findings that you can later on browse through and use for enforcement reasons or just for additional context. It plugs into the Kubernetes admissions controller. So you have Kubernetes deployment anywhere. You can use Kubernetes, and it would enforce signature-based policy or vulnerability-based policy for you at deploy time. As I mentioned, that we have a number of support from partners, and it's open source, built with community. Contributions are welcome. Check it out if you're interested. So with this, we hope to create an open ecosystem where you can pick and choose which component which vendor you want to use for each of the component. You may have a different build process using CircleCI or CloudBees, and you may have a different scan process based on Black Duck or Twistlock. And you may choose to use Spinnaker, or you want to deploy manually. It does not matter. We want to create this general framework where you can still record the metadata, the signatures, and the findings in the databases that you can centrally access and manage. We still want to give you the ability to control what goes into a production environment using the Kubernetes admissions controller to enforce that policy centrally as well. So here, with the open source tools that we've published along with our product, we hope to achieve that. All right, so we talked a lot about technology. So how does it work for a real customer? Rakesh, you want to show us?
Thank you. So I'm going to do 2 or 3 things in this next segment. So I'm going to talk to you about what we're actually doing as a bank. I'm going to then talk to you about why we're doing it, and then show you a small snippet of how we've put that into practice and what does that mean for our organization. So let's start with the what. Now it looks like a very busy slide. It's there deliberately. It's there to show you the complexity of where our organization sits in terms of engineers getting code out the door to customers. So what we've been doing is we've been working with our engineering teams across the organization to say, what would you like? What would this process look like? If you wanted an industrialized CI/CD capability, how would it look? And what are the key elements you require to make that journey to the customer as seamless and as quick as possible? I'm not going to talk through all of it, but what you're basically seeing is from left to right is a typical CI/CD pipeline. We do a bit of code scanning. We're using checkmarks at the moment, or static code analysis checkmarks. We're doing CI with Google Cloud Build. I can see the guys in the audience who are actually using Black Duck for code scanning. One of the aspects you're not seeing there is we're doing vulnerability scanning with Twistlock at this point in time. But for us, it's the ecosystem model where we can pull and plug tools and actually integrate them with Google's offering. And as you progress towards the right-hand side, we've chosen a continuous delivery tool, Spinnaker, to help us with our deployment capabilities to do, at the moment, just do deployments, but maybe move towards some clever items such as canary deployments or blue-greens, or wherever we may end up and what our engineers want to use and what our teams need to make their lives easier. The other bit to call out here is what you're seeing in terms of the complexity of those numbers is where we plan to build these attestations, or as Sandra called them, signatures. So the idea is that as things progress through these pipeline or this pipeline capabilities, what will happen is these attestations or these signatures will be created, and then binary authorization with Spinnaker will enforce that they are available and present when we try and deploy a container. So as a container progresses through this and gets to Spinnaker for deployment, if it doesn't see all the attestations, and binary auth basically says that this does not fit with your organizational policies that we have defined, it'll block the deployment. So for us, the value add here is a range of things, but for us it ensures that the organization, when it's deploying containers into production and goes to our customers, it's met a set of requirements that we are comfortable with as a banking organization. So why use this capability? So I've already referred to earlier on around the engineer's experience, which is critical for us as an organization. We want to ensure that the engineers have a seamless way to get what they're building into our customers' hands. I've already highlighted the speed aspect. In a digital world and with the transformations and the changing competitive landscape, speed to customer is key. As we build a new feature, we want to get that into our customers' hands as quickly as possible. But then we start to move into the real value add for me. Kind of what I've described as, CI/CD pipelines and stuff we've been doing as an industry for a while. But the critical value add for me is how we then use binary authorization to automate our governance. So as engineers utilize these pipelines, as an organization, in terms of our breadth of 50,000 employees, we can be sure that anybody there pushing workloads to production meet a set of organizational policies that we can enforce, change, and redesign on the fly using this capability, which gives us the ability to do technology governance as code, essentially. But that's not enough for us. So what we're then starting to think through is to say, well, if we're enforcing technology governance as code, and we're using these capabilities to ensure that we don't break our appetite from an organizational perspective around tech, well, why couldn't we do that with some of our other requirements in terms of our organization? What about our business governance? What about our risk appetite as a bank? Can we not start to codify some of those aspects and start to enforce them via these sorts of capabilities? Now, that's just something we're starting to think through and starting to adapt. So it's very much an open question mark, but that's where we're heading towards, is starting to look at, as an organization, how do we govern ourselves? How do we manage ourselves in terms of risk in an automated way, and using something like binary auth to enforce that where we do something, it doesn't change our core values, or it doesn't change our core requirements, or it doesn't change what appetite we have as an organization. And again, just to draw off, as we start to progress that world, how do we then use this to show compliance across 30-odd regulators? We want to do that in an automated way. We don't want to be demonstrating a set of documents or a set of requirements in a different format for whether it be APRA or MAS in Singapore or whoever. We want to ensure that they have the ability and they have the confidence that they can explore these capabilities with us, and that we can give them the confidence that we can demonstrate compliance differently. So that's the kind of what we're trying to set out to do, and why we feel that there's a good business case and good appetite for us to go and do this. We're going to show you a very short video as we hit play. So I want you guys to bear in mind, this is just our MVP. It was kind of what we started off with, but it should give you a feel for how some of these tools are coming together to make what I've described and what the team have described come to life. So what you're going to see in this first part of the video is basically cloud build being used to execute some CI. So this is the aspect of where we could also add complexity by integrating with Black Duck, integrating with checkmarks, and actually starting to validate that our code that we're building and our CI capabilities are fit for purpose. What we then will do is, as we've built the artifact, we'll then try and deploy it. So what you're seeing here is Spinnaker attempting to deploy the artifact we've just created. What you'll see at the bottom there, or just about, is that the build failed. And what you can see here is, as we highlight, I think we're just moving around. Bear with us.
Yeah, 1 sec. I want to make sure that we have the high quality because it's really blurry.
Okay.
Excuse me.
It looks good on this screen, so sorry about that. We can just quickly rewind back a little bit if people haven't seen. So we use Spinnaker to attempt a deployment. So the key aspect to see here is that our CD tool is trying to deploy the artifact we've just created. And what you'll see there at the bottom is that that's failed. And when you look into the information about why it's failed, you'll see there it actually says that no attestation was found. So we'd configured Spinnaker to look for a particular attestation. So as I described earlier, that can become more complex. This one's just a single attestation, but it can become numerous. What you're seeing here is us manually creating an attestation. Now, in a normal pipeline, we want as many attestations to be created or in an automated fashion, but we still want to keep the ability that where we have manual intervention, we can manually create an attestation, and that's where we're going to sit probably in the short to medium term. We know this is an evolving journey for us. And then what you'll see is, as we progress and the attestations be created, we'll trigger that deployment again using Spinnaker. Again, you'll see in a manual deployment, but we've actually now automated that. And this time what you'll see is Spinnaker will execute, and that deployment will be successful. And the reason it's been successful is this time, as it's tried to deploy, it's actually looked for that attestation, it's found that attestation, and actually then basically said, yep, it meets the organizational policy that's been defined previously. And then the video just finishes with us basically refreshing the console, and what you'll see this time, hopefully, well, I know hopefully it's a video, so it's been predefined, that it's there, and it's successful, and there it is, green, available for consumers to use. So we wanted to just give you a short video, one, because I'm not overly technical, so me trying to do that on the fly would have failed miserably, but two, it's just an MVP that we've developed a while back. So what I want you guys to take away from this is that complexity I showed you in terms of our overarching CI/CD pipeline, the different types of attestations, and this is just a way to bring all of that to life and to say this is how we're going to continue to add complexity as we evolve that capability out in the bank. So I think it was just a couple of final comments from me, really. So it's been hard and challenging, right? So I mean, you're trying to change an organization from a number of fronts, and you're trying to embed some of these practices, these ideas, and it's challenging for a whole range of reasons. I think if anybody here has done transformation programs, you'd attest to how difficult trying to push some of this change through is. We have basically said it's definitely worth the investment and the effort. So it's been hard work, and it's been a bit of a slog. However, we're already seeing the benefits of the work we're doing, and we're not even fully all the way through our journey. We've got, probably 2 or 3 iterations of our pipeline. We've got more to do. We want to start to tackle the organizational stuff, and we've already started to see the benefits and the business case for how we continue and accelerate the work we're doing. So the first bit for us is just stick through that initial challenge phase. 2, interestingly enough, what we found was as we started to embrace some of this and put some of this into practice, it actually started to inform us of how we needed to evolve some of our technology landscape wider afield, whether that be on-premise or some of our thinking or some of our overarching processes. And we've managed to shift left some of that work. So we've managed to actually identify things that could have been a problem 2 or 3 years down the line by actually embracing this world and actually getting on with this aspect that then informs the other things that we need to change. And thirdly, it's often said with a change program, bring people on the journey, and it's usually said because, it's the change process and you get people on. But what we've found is actually the reason to bring people on the journey early is that they started to get involved in this, and they actually really loved it and enjoyed it and actually started to want to be part of it. So we've started to see a real cultural shift and a real coalition around the organization of people wanting to adopt the work we've been describing. So not only spread the message and bring people on journey to help them embrace the change, but actually what we've found is we've just found helping hands across the organization to make this a reality for us. So I think we're into closing remarks. So the only bit for me to close with is hopefully what you've seen is ANZ's approach to kind of how we want to change some of the things we do. I've described a little bit of the why we need to do that, and hopefully I've brought together kind of how we're using some of the Google's capabilities to bring that to life. And we have 2 main outcomes. One is to make ANZ an amazing place to work for engineers, but 2, as quickly as possible, get consumer value out the door and get it into our hands of our customers. And we see the work I've described as a critical aspect to achieve both those goals as we move forward. So I'll hand back to Google.
Thank you, Rakesh. So as we've seen, the applying security in the Kubernetes supply chain has some challenges, but also creates great opportunities to both apply that security, enable your teams to create and to take advantage of that velocity, and as a result, to provide your customers with great experiences and maintain their trust. So here's a summary of some of the products that we talked about today. They are available, as Sandra mentioned, vulnerability scanning and binary authorization are going GA soon. Managed base images are available for you to use right now. So these are some great resources that we make available to you, and we look forward to having you use them and give us feedback. And here are some related presentations on the topic of security and containers. You can find the videos for these presentations on YouTube now or in the near future.